So it's basically the model with the autocorrelation plus some randomness. And the randomness, we've actually really done this already before when we built these models. You remember this?
Mm-hmm.
Let's get rid of the second term. So this is basically like one autocorrelation. And what we see here is just basically this coefficient that we look at when we run the autocorrelation function. So we could effectively do the same here. We can do a plot PACF, yeah, and then put in X. We need to do this first. No shape. It's because we need to wrap this into an array. This is a list at the moment, but see, this is interesting. We have the autocorrelation 1 is 0.5. And so we get a statistically significant peak at 0.5, and then no more statistically significant stuff further down the track. So can you see how this fits together?
To a certain extent, yes. I mean, like, my question would be, because I was, I think, also struggling with that, to get the S&P values into it. Like, how do I know that a list doesn't work with a plot PACF?
Oh, yeah. Well, this is kind of a Python thing.
Mm-hmm.
So in Python, a lot of things. So actually, I knew that it doesn't work. I show you why I knew it doesn't work. So let's just go back to the list. And look, it says here, list has no attribute shape. Yeah.
Mm-hmm.
So what I know from NumPy is that in NumPy, when you have a NumPy array, so let's just make this an array again. We basically have this function called shape here. Yeah. So if you go .shape, it gives you the shape of this.
Mm-hmm.
Yeah. So it's 502 entries long. Now, you can't do this with a list. A list doesn't have a dot shape.
Mm-hmm.
Yeah. Gives you an arrow. It just tells you length X. Yeah. So if I go length X, it will tell me it's 502 elements. Yeah.
Mm-hmm.
Now, if this asks me, it says, hey, there's no shape, and I know what I produce here is a list, I say, actually, it doesn't like the fact that it's a list. It needs to be an array. So in Python, you have basically a difference between arrays, which is effectively a typical, like an array in C++, or you have a list, which is a doubly linked list. Yeah. And NumPy doesn't do doubly linked lists. It just does arrays. And that's why it's much faster, because when you do calculations on a doubly linked list, you cannot access indices directly. You always have to traverse the list to get to the indices. And that makes it kind of slow, right? Mm-hmm. So a lot of those mathematical functions, they love arrays because they can do this really fast, whereas a list is slow, right? Now, what they could do is they could say, well, if we see a list, we turn it into an array, but a lot of these functions don't do that. They just assume you give it an array, right? Mm-hmm. And hence, we basically turn this into an array, and boom, it works, right? So sometimes that's a bit of an annoyance with Python, because it doesn't have a type system. You just sometimes need, so to speak, the experience to know, it's a type error. It's not obvious, right? But that's why Python is so easy to use, because you don't have to worry about this generally. But sometimes you do. In this case, you see it's not type safe. Like, right? We put in the wrong type. There's no error message or anything. It just says, I can't do this. That's a danger in Python sometimes.
Okay.
And you just have to, it comes with experience to figure this out. And likewise, you probably had a difficulty with this here because you didn't drop the nut.
Actually, I did. I didn't do the zero. I didn't put the zero into it. But
the zero was actually wrong. You don't need a zero here. You just drop an A, right?
I tried that, but it also threw me an error, and I was like, I don't know, right? What the problem was with this, but yeah.
Yeah. but there you go. I mean, it's just how,
Yeah.
It's kind of experience. I mean, when you use Python a lot, then after a while you just, you get the same stuff over and over again,
Yeah.
and then after a while you just get used to it and you go, that's the problem, just as I did. It's like with anything. It's like with C++. You just know, that's the problem. When you're new to it, you just fiddle around and you can't get any resolution of the issue. But like after a while, you just get it, right? And you go, that's the issue. Boom, and here you go. So it's more like experience makes you better at this, and then sorting out, an untyped language just has its own issues. It's fun and quick sometimes, but it can also be a pain in the butt when you can't figure out what the issue is. In this case, it was a typing problem, really.